Axiom Space and NASA are working towards a continuous heartbeat in space. And that isn't talking about astronaut safety, that's talking about a continuous presence in space. I'm going to talk about the distinction and why we're even talking about this and what Axiom is doing to switch it up and whether it's going to work in the first place, whether we're going to see a gap between the end of the International Space Station and the beginning of commercial space stations in low Earth orbit. The news came out today that Axiom is changing around the order of its modules. So it first envisioned having the Axiom's habitation module, HAB1, dock to the International Space Station first. That would hold 4 astronauts. That would be the beginnings of Axiom Station while attached to the International Space Station. But now they've decided to change the order of things, and I'm going to tell you why. First, they're going to put that power module. That's called the Payload Power Thermal Module, and they're going to add that to the International Space Station first. And then they're going to add the habitation 1. They're not going to have the power module attached to the International Space Station when they add the HAB. They are just going to have the power module attached to the International Space Station and then eventually detach from Space Station, then attach the habitation module HAB1 and have a 2-module space station, which they will then expand from there. Their order of things is the power and payload thermal module first, followed by the HAB1, followed by an airlock, followed by HAB2, and then finally a research and manufacturing facility. That's their current order of things. My first full-time job was actually facilitating International Space Station research. So this has been an interest of mine for a while. And even though it is an interest of mine, at the end I'm going to talk about something that we don't ever really talk about, which is a world beyond microgravity space stations. But I'll get to that later. First, I want to talk about why Axiom is doing this, why NASA is encouraging Axiom to get its space station up more efficiently and quicker. Because Axiom is saying they could have that first module of the space station attached by 2028. I want you to pause for a moment and then consider that the International Space Station is currently targeted to be deorbited in 2030, and Axiom is saying that by having it up there in 2028, that's 2 years earlier than planned, so 2030 was apparently their time frame, which brings up concerns about a gap between the International Space Station and commercial companies. And I'm going to talk about that, especially in the recent decision that NASA just put out this week about having a continuous heartbeat in space. That is human presence, humans in space, in low Earth orbit, continuously. Getting back to why Axiom is making this change, there's multiple reasons. One of them would be saving time, like we just said. The other one would be freeing up a key docking port. So right now, the International Space Station is targeted to be deorbited in 2030 or so by having SpaceX attach a US deorbit vehicle, it's a modified Dragon, onto a docking port called Node 2 Forward. And unfortunately, Axiom was planning to use that for HAB1, for Habitation 1. And so Axiom has decided to deconflict that docking port so that now SpaceX can have that docking port to attach to it anytime NASA decides that it wants the US deorbit vehicle attached to the International Space Station to begin those deorbit burn maneuvers. Now, Axiom instead is going to be using one of those cargo ports. Think about the SpaceX Dragon or Northrop Grumman Cygnus. They attach to these docking ports for supply deliveries. And so that's what Axiom is going to do. They're going to attach their power module to one of those docking ports. But for how long, they haven't really said. In their press release, they said it could be a short term or long term. Is this even a real thing? Are we just talking about paper plans at this point? Well, no, because Axiom has actually been working on this since February of 2020. They have Thales Alenia Space in Italy working on building actual hardware for this. Thales Alenia is actually going to repurpose. They had been building HAB1 and HAB2 already, and they're going to repurpose some of that hardware for this payload power thermal module. And so it is actually realistic to think that Axiom will actually have this power module attached to the International Space Station before the space station is deorbited. But one thing that piqued my interest about this change is that why does Axiom need to be attached to the International Space Station in the first place? All the other commercial space station plans are free flyers from the start. So Axiom's plan is to be a free flyer eventually, but to first attach to the International Space Station. Aside from contractual reasons, because that was the contract NASA gave them, why? Because with the previous configuration, the habitation module was going to use the power and utilities of space station for its Habitation 1 module. And now with HAB1, not even ever touching the International Space Station, not ever being attached to it, just being its own free flyer with the power module. Why have the power module attached to space station? So I dug into that a little bit. The press release does not give details. It does say that they want to do testing, practicing, learning how to operate in space, and burning down some of the risks by attaching it to the space station. And I wish they went into more details there, because I can see it both ways. I can actually see attaching to space station and being part of space station actually increasing some risks in some areas, especially to space station. But I wish they had gone into more detail about what kind of mitigation of risks or testing or any kind of commissioning activities that they need to do while attached to space station that they couldn't do as a free flyer, or would be more difficult to do as a free flyer. One reason why this contract was set up like this in the first place, back in 2020, NASA was going through a bit of a phase, I guess, where it was heavily promoting the space station for commercialization of the US industry. And I think it was just like justification for space station in a way. NASA had this reasoning that it had not done enough to encourage the commercial industry to, facilitate growth, develop technologies, develop a customer base and a market, that kind of thing, and that space station could be used to do this. And so NASA had various ways that they wanted to encourage the commercial industry to use space station to, build an economy, build a space economy in space. And one of the ways they decided to do this was to have a solicitation to attach a commercial space station onto ISS to help kick that process off, because this is before any commercial space stations were like a real thing. Sure, there were proposals. There have been proposals for decades for commercial space stations, none of them realistic. And so NASA decided that they would sort of incubate a commercial space station by having it attached to the ISS to begin with. And they chose Axiom Space for that contract. And the contract states, or at least the press release from February 2020 states, that NASA selected Axiom Space of Houston to provide at least one habitable commercial module to be attached to the International Space Station as the agency continues to open up the station for commercial use. So at least one. So this change in plans that Axiom is doing is one, right? It was initially planned to be 2 or 3 modules, and then it would break away from space station and be its own thing. Now, just one module attached to space station, and then it's going to break away and be its own thing. That press release from 2020 also states, developing commercial destinations in low Earth orbit is one of the 5 elements of NASA's plan to open the International Space Station to new commercial and marketing opportunities. So I really do think that this was just a way that NASA decided they wanted to help commercialize the low Earth orbit community in a way, to build up that customer base, to build up the facilities, to build up the capability. One additional reason why NASA might want a commercial module of any kind to attach to space station before it breaks away and before space station is deorbited and completely burned up in the atmosphere with the rest of it falling into the Pacific Ocean, like there's valuable stuff on space station. There is 25-ish years of equipment and logs and mementos and things that have just accumulated that are valuable both scientifically and also like sentimentally, even anthropologically, if that's a word. I'm sure it's a word. So NASA has been talking for a couple years now that they want to discuss and prioritize what can be brought down to Earth and put in museums, what can be brought down to Earth and reused, and what can be kept in space on commercial space stations, specifically facilities. A lot of the science that it's done in space station, or even just the daily use, is done by specific facilities, equipment that really does no good on Earth. We need to use it in space. And so NASA has been talking with international partners about transferring some equipment that it already has up there, not just NASA, also European Space Agency, Japanese Space Agency, JAXA, Canadian Space Agency, like all of them, they all have equipment up there. And they've been discussing internationally as a collaboration what can be saved, what should be saved. They have certain mass and size constraints with transferring equipment, and some stuff can be brought down on those Dragon and Cygnus craft that I mentioned earlier, as well as Soyuz from Russia's side. And I suppose Russia is involved in those collaborations as well, but I don't know how much. But what can be saved and transferred over to Axiom or brought back down to Earth and then transferred up again to be on another commercial space station by another provider. And it's just so much easier if you have Axiom Station already attached to ISS to transfer, right? You just kind of toss it and it floats, maybe more involved in that, but like it's pretty easy, right? Comparatively to transfer some of that equipment over to Axiom Station. So that does seem like good justification for me to even have any module attached to space station before space station is deorbited, and then have that commercial space station continue on that legacy. Now, speaking of continuing on the legacy, NASA earlier this week published the Low Earth Orbit Microgravity Strategy. And this was a document that they put out a few months ago in draft form, and they asked for input from the community. They got a lot of responses. And so this week they finally published the final version of it, which really discusses what they've decided in terms of what they want with commercial space stations. If you remember 2 months ago during IAC, NASA Deputy Administrator Pam Melroy, she made some surprising statements about a continuous heartbeat in space versus a continuous capability in space. And this is somewhat surprising because for decades, we've all just assumed that a continuous presence in space meant people continuously living, a continuous heartbeat, right? We'd never even talked about the term continuous heartbeat in space. And so the discussion apparently internally at NASA that was going on at least 2 months ago was that, is it realistic? Is it feasible to have that continuous presence in space, that continued heartbeat in space? Or do we need to compromise and just have the capability, have the facility up there that we can have sorties, at least in the beginning, before these commercial space stations are really ready to take on full-time residents? And NASA decided in this microgravity strategy document that they published this week that no, they really do want a continuous heartbeat in space. And the reason why, there's several reasons why. But first off, since November 2nd, 2000, there have been people living and working in space continuously on the International Space Station. There's justifications as to why. And so NASA listed a few in this document. I'm going to read them really fast and then go over in more detail. Reduce risk for sending humans to Mars. Preserve critical operational skills, maintain a steady transportation cadence, continue advancing science, and sustain engagement with commercial and international partners. So those are the reasons why they want a continuous habitation in space. If you're heading off to Mars and it's a long trip with current chemical technology, chemical rocket propulsion, then you cannot have like just breaks, right? You need to know how to live and work in microgravity conditions continuously. And we have done studies now for how many decades about living for 6 months, a year, even in some cases longer than a year in space. And we know how difficult that is on the human body, how harmful it can be on the human body to even live days in space in microgravity, let alone a year or more. But this is something that NASA wants to keep continuing as we prepare to send humans to Mars. And same thing with preserving operational skills. If you take a pause from something, let's say sending humans to the moon, you take a very long pause and then you try to do it again, you've lost a lot of institutional knowledge, you've lost a lot of that skill that had accumulated, the operational skill of how you even do that. So now we're having to relearn these skills, and we don't want to do that necessarily with living continuously in low Earth orbit. We want to keep that unbroken practice, that ongoing commitment to keep living and working in microgravity conditions in low Earth orbit. To maintain a steady transportation cadence means that NASA knows that it has commercial partners that rely on NASA's regular expeditions to the International Space Station in order to predict its business, right? SpaceX in particular has been the really reliable partner in the recent years, since May 2020, of sending astronauts to the International Space Station roughly every 6 months for every expedition. If you look even at the supplies, Northrop Grumman and anyone else who chooses to supply the space station, having that regular cadence or knowing that regular cadence is coming of the supplies, cargo delivery, cargo return, the astronauts coming and going, that is really important for predictability. Continue advancing the science. They actually get into that a lot, so I'm going to talk about that a little bit later. And sustain engagement with commercial and international partners. So I talked about the commercial partners, and it's not just transportation. It's also other commercial partners. Think about like Redwire, made in space, right? The equipment that they are continuously producing for use by astronauts in the International Space Station and commercial space stations in the future. Think about all the international partners that are currently involved in space station minus Russia. All of them are going to want to continually have that opportunity to send astronauts, send their own nationals to space, to do their own research in space, collaborate on research in space, to, in other ways, use the LEO environment. And so having that international partnership continuously is important, especially when it comes to U.S. leadership with China. And I'll talk about that in a moment too. Because the document also states, with the added motivation to maintain leadership in space, continuous heartbeat in the era of commercial low Earth orbit destinations is logically required. So that means that U.S. wants to maintain leadership in low Earth orbit. And China has its Tiangong space station. That has the continuous opportunity for Chinese nationals as well as anyone else the Chinese invites. And it has been discussed for quite a number of years now that China is a bit of a competitor in space to the United States and its allies. And so if China is the only one operating a space station in low Earth orbit and the International Space Station is retired, and let's say commercial space stations just aren't up to the task of having continuous habitation in space, then it looks bad on U.S. leadership. And so the United States doesn't want to be in a position where its international partners say, oh, the International Space Station is gone and commercial space stations are just not ready for us yet. So we're going to go talk to the Chinese about flying our people, research, whatever it is. And that brings us to the topic of a gap, because for a couple of years now, it has been theorized that NASA might have to accept a gap in capability of access to low Earth orbit. So that being the International Space Station retires 2030-ish, and there's no commercial space station that's ready. And so one of the ideas floating around is to continue to, delay the deorbit of the International Space Station, which is still an option. This strategy doesn't talk about that. That is not desirable for a lot of reasons, but it is an option. The other thing would be to speed up commercial space stations. Now, Congress, during the beginning of the Commercial LEO Destination initiative, was not willing to completely fund the commercial space stations the way that NASA requested. This changed after a few years, so now they are getting the investment that NASA is asking for, but it's probably a bit too little, right? And so even though they're commercial space stations, NASA knows that it needs this capability, it wants this capability, and therefore it's willing to invest and be an anchor tenant. But it can only invest what Congress gives it. And so it's kind of stuck between a rock and a hard place. It's trying to eliminate any gap between the end of International Space Station and the beginning of commercial space stations, but at the same time, it can only do so much with its limited funding, which brings us back to Axiom Station and why Axiom Station is currently reorganizing things to be able to fly 2 years sooner, as they say, hopefully before the International Space Station is retired. Russia, although a partner in the current International Space Station, is not going to be a partner in commercial space stations, not going to be a partner in NASA's future big programs like Artemis program, that kind of thing. Russia has been a wild card as of recently, if you've been following any kind of news about the hijinks that were going on since the start of the Ukraine war in 2022. Some of the things that the previous Roscosmos had said. The director of Roscosmos was Dmitry Rogozin, and he was very much not a fan of the United States of America. The current head of Roscosmos, Yuri Borisov, he said something in an interview earlier this month that indicated that Russia will actually continue the partnership on the International Space Station until its end. And this was a question, believe it or not, because all the other international partners, like I said, ESA, JAXA, Korea, all the other international partners on the space station had agreed to keep ISS going until at least 2030. And Russia, because of the way that their funding, their budget works, it's like every 4 years. And so they had only agreed up to 2028. And the question was, are they going to keep that commitment? Are they going to extend it to 2030? Are they going to deorbit it sooner? Because there were comments made that maybe they were going to deorbit it sooner. However, it does seem that with these latest statements from Yuri Borisov that Russia is committed to the ISS until at least 2030. And he said, translated from Russian, he said, in coordination with our American colleagues, we plan to deorbit the station sometime around the beginning of 2030. The final scenario will probably be specified after the transition to a new NASA administration. So even he's opening it up to the possibility that the new administration is going to change things and say, we're not deorbiting 2030, we're going to deorbit later or sooner or whatever. We just actually don't really know what's going to happen in the next administration. I would guess that they're going to keep on going the same status quo, but who knows? Which brings me back to this strategy document that NASA put out. NASA in this document stated that not only do they want a continuous heartbeat in space, they want multiple providers, a diversity of providers. And so NASA's saying they don't just want Axiom Station, they want these other partners too. NASA also is working with Orbital Reef, which is a partnership between Blue Origin, Sierra Space, and some others. They also want the success of Starlab, which was a NanoRacks Voyager project, and now it's its own entity, under Voyager. And they also want other entities that they haven't even given contracts to, at least paid contracts. There's Space Act agreements. VAST, which is working on Haven 1, which is not a continuous heartbeat, by the way. That's not a continuous presence, but the larger space station they recently announced, VAST Haven 2, that one is capable of having continuous heartbeat as far as I understand. And so NASA is working with these other partners because they want more than one to succeed. I think NASA's learned quite a bit over a long period of time that dissimilar redundancy is important. Don't just have one. What happens if today something goes wrong on space station? That leak that's been going on for quite some time, what happens if it gets monumentally worse? What happens if orbital debris hits space station and they were unable to avoid it in time and it collapses the space station, right? When I worked for space station, I had nightmares like this. The movie Gravity came out, and I know it was a silly movie, I know, but the movie Gravity came out, and we as a company went on a company trip to the movie theater to see the movie Gravity. And it was just like one of those nightmare scenarios, like, oh, my job could be gone tomorrow because something could go wrong with space station. So we don't want that. We want a future where there's multiple space stations in low Earth orbit for the continuation of science and human presence. So that is what NASA is saying, and they have several justifications. And in fact, a lot of what they wrote in this strategy document that they just published could apply to the past 25 years of International Space Station. There's really nothing new here, but I still want to go over some of the rationale they used for why they included some of these things in the strategy document. It is a short document, by the way. I'm going to link it below. I encourage you to read it if you're interested in any of these. I'm just going to go through some of these highlights. Microgravity research is crucial to advancing both knowledge of ourselves and our planet. And I don't think anybody could argue with that. Microgravity research is something that we're still just beginning to understand and dive into. NASA's biological sciences research both enables exploration and benefits of life on Earth. Effects of Earth's gravity hide key interactions in many experiments, and this is particularly true they talked about in physics. There's a lot of things that you can do in physics if you just turn gravity off as a parameter versus having the 1G environment that we are used to here on Earth. Human flexibility and rapid iteration. So I feel like this is a topic that gets discussed a lot outside of space circles of why even bother with human exploration when things can be done robotically. Why have a space station with a human presence when you can just have satellites or uncrewed facilities, platforms that can do science? Because a lot of this work does actually require or benefit from humans. When I worked at ISS National Lab, it was so important for some of these experiments to have a human in the loop. It could be a human who sets it up and presses the button and go, and then it's just done, and then collects the data later. It could be a human who is, occasionally monitoring something, or it could be a human who is continuously involved, has to spend hours doing something. And you can't really replace that with a robot, at least not at this time. Robots don't have the dexterity. Robots don't have the, AI. We say AI, but there really truly isn't artificial intelligence yet. Humans are the only ones who can really think in the moment, to quickly adjust, to quickly iterate, and to be flexible. So I went on a zero-G flight when I was in grad school where we had an experiment that wasn't working the way we wanted it to. And the way that zero-G flights work is that it climbs and it dives and climbs and dives. The plane does, the plane climbs and dives. And during the dive is when you get about 25 seconds of microgravity. And so we were able to experience a dive, see that we needed to change something. And before the next climb and dive, we were able to fix it and improve the experiment on the fly. And that's something that just cannot be done without humans at this time. And then, of course, there's the actual research and technology development that needs a human because it's a wearable. It has something to do with medical changes on astronauts' bodies, stuff like that contributes to humans living and working in space long term. And then there's the location. There are some things that can be done on space station that simply cannot be done elsewhere. Measurements from low Earth orbit are essential for advancing NASA's space and Earth science disciplines. And then there's things like international cooperation, workforce development and STEM education, and public engagement. And then here I pulled out some justifications, some rationale at the end that are all related that I want to talk about. Living and working in microgravity environment requires a wide range of unique skills. Establishing a sustained human presence on and around the moon and Mars, and ultimately throughout the solar system, requires advanced technologies and capabilities. As human exploration extends beyond low Earth orbit, NASA must progressively demonstrate the ability to safely and effectively live and work in the lunar and Martian environments for extended durations. Low Earth orbit provides an opportunity to progressively work through operational aspects of Moon and Mars exploration missions that are best simulated with crew in space, including their ability to effectively function in a gravity environment immediately following extended time in microgravity. So all of that is related to lunar and Martian exploration. And this is an area where I can see the benefits of microgravity research, but I can also see that microgravity research might not be the best way to practice to live and work on space. One of the benefits is it's a closed system, or at least mostly closed system, right? You recycle the air, you recycle the water. In the future, hopefully we'll be growing more edible food for the astronauts to actually eat. Right now it's more like just growing it for science. And having that ability to learn how to live and work in space in that closed environment, in that tiny little environment, is very, very valuable. And that's something that even though we've been doing this for decades, we still haven't really figured out to maximize the efficiency. We've gotten pretty good at it, but I don't think we're experts at it. So practicing in low Earth orbit, practicing in microgravity on space stations is something that can directly benefit us as we live elsewhere off planet. However, I would argue that working and doing any kind of operations and research in microgravity is probably not going to directly correlate to lunar gravity and Martian gravity. Those are reduced gravity bodies. And we just simply do not know how to live and work on a reduced gravity environment until we try it. You know, we're so used to 1G. We have now decades of experience in relative 0G. And we have no real experience in lunar gravity and Martian gravity other than the very short stays during the Apollo astronauts, 1-2 days at a time. And that's very, very little. So what we need to do is actually go to those bodies to learn how to live and work there. We don't know how much of the medical research that we've done on microgravity conditions, microgravity physiology, translates to reduced gravity. We don't know how much of a gravity body is needed to mitigate against some of these health concerns or to make things a little bit easier for the astronauts. Things aren't just floating away, they can actually stay where you put them, that kind of thing. Some of the medical technology, or really any technology that requires fluid dynamics or pressurization, that kind of stuff is so different in microgravity compared to even just a little bit of gravity can help. A little bit of gravity is more going to be analogous to Earth, even if it's not 1G. So these are just things that we have not tested that I don't think that ISS is the best testing ground for. I think we actually need to go to the surface of the moon. We actually need to go to the surface of Mars and test some of these things out. And one thing that is just not discussed at all in this strategy document, or really ever at NASA, is artificial gravity. There has been so many people who have proposed artificial gravity and ways to do it. And I think even the Japanese have tested it a little bit in a small little centrifuge with rodents on the International Space Station. But there has been such little development in this area. And as a physicist, I actually thought once about using my physics degree to create a company to work on artificial gravity, but I am really bad at fundraising. So I decided to stick with my consulting company. And also I've got colleagues and friends who are working on artificial gravity companies and technology, and I just rather support them in what they're trying to accomplish, because as we think about the future, right, there's two distinct visions of our future, and I think that they're not mutually exclusive. I think that both could happen. One would be a world where we have people living and working in microgravity conditions in space, and that could be low Earth orbit, that could be elsewhere in our solar system or beyond, just forever being on space stations, on space vessels. Think like Star Trek, or really any science fiction where they're traveling, right? And those people have gravity, at least in the movies, because that's easier, right? But it's also going to be beneficial for humans, and thinking about reproduction and all the things that we don't know about how to reproduce in space, the ways that we might need to actually have multiple generations in space that we just cannot even conceive of in microgravity conditions compared to gravity conditions. The other vision is living on planetary bodies, right? Living on the surface of the moon, living on the surface of Mars. And in that case, we still need to figure out long-term microgravity, because we still need to get to these bodies, right? The moon's right there, but Mars is far. And what happens if we want to go to another planetary body that's even farther that we might want to settle? I think about the Expanse, and they've really, settled the belt, right? There's so many different examples of places that we could go if we wanted to. We could expand out there, but it takes a while with current chemical propulsion to get there. And so we still need to have a means of protecting humans against the harmful effects of microgravity by hopefully having artificial gravity developed and tested. And so this is something that NASA has not touched, mainly because they don't have the money. I think that there are lots of people within NASA who would love to study this. There's no political motivation or budget to study artificial gravity at this time. And going back to the idea, that Yuri brought up, that the next administration is coming. Next presidential administration, next NASA administration with Jared Isaacman as the presumed next NASA administrator. All of this can change, right? I think that at least one commercial space station will succeed, but we don't know how the priorities and budget of NASA is going to transition with the new administration. There might be boatloads more money, but probably not. I really doubt it. There is going to definitely be a change in priority, and I don't think space stations are a high priority for this incoming administration, so they might keep the status quo and everything goes exactly as NASA and Axiom and the others are predicting. Or we could see harder times for commercial space stations in low Earth orbit. Another thing I did not discuss because it's not in this strategy document because it's not in low Earth orbit, and that is the Lunar Gateway. That's the space station that is in that weird halo orbit around the moon. And that is something that is not going to have a continuous heartbeat. They are planning sorties, and I've already talked in another video, which I will link, that it's just not necessary. Gateway is a cool idea if NASA had a lot of money, but NASA does not have a lot of money, and Gateway sucks up a lot of money, and I think that could be canceled or transitioned into another orbit of some kind. I don't know. But there are lots of things that could change with the next administration, and I will keep you in the loop.